Hello everyone, welcome back to mahasarkar.co.in. In previous video we have gone through the isothermal process and we learned that if temperature of system is remaining constant, then internal energy gained by system is also constant. Or sorry, instead of internal energy, kinetic energy remains constant, so gain in internal energy is what? 0. So heat provided to the system directly transferred as what? Work done to the system, work done over the system. That system we called as what? Isothermal process. Now in this system in this video we are going to learn about isobaric process. So what is isobaric? Barometric. Iso means constant. So barometric value means pressure. The system in which the pressure system constant pressure system is called as what? Isobaric process. In this system delta P is supposed to become what? 0. Before that, here pressure is not changing. So some pressure is definitely there with the substance. So if you add the heat, the part of heat will be transferred to the system as internal energy and the part will be transferred as what? Work done. So none of this here delta U, delta Q and delta W don't become 0. Then none of all these three becomes what? 0. So before going with this process, we need to clear few definitions. We know that the rate of change in internal energy per unit temperature is called specific heat capacity at constant pressure. It is called as what? Specific heat capacity at what? Constant pressure, indicated by C. Therefore, n number of molecules and Cv is equals to all of molar specific heat at constant volume. Okay, then it is called as what? Delta U upon delta T. This formula you will require. Also, the difference between Cp minus Cv is equals to R. If you remember, you have gone through this relation in the previous lesson, that is kinetic theory of gases and radiation. Okay, so now what we are going to find out in isobaric process, we are going to find out the work done. But here let Vi be the initial volume of system, so the corresponding temperature is Ti with the initial temperature of system. Okay, I am writing little in short. So Vf be the final volume of the system, and Tf be the final temperature of the system. If I want to write the work done, then we know the basic formula, work done equal to what? P into dV. So this equation number 3 in this article. I have already written these two equations. So if I replace dV by this one, then how will you get? Therefore, work done from changing the volume, changing the volume from Vf to Vi is, say, how will you write? W is equals to P into, what will write? Vf minus Vi. Okay. If I want to represent this work done in terms of change in the temperature, then I can take this P in the bracket. So P into Vf minus P into Vi. But by ideal gas equation, P is equal to what? nRT. So I can write this. Therefore, work done equal to what? nRTF minus nRTI. nR is common, so it will be what? Tf minus Ti. So this is equation A. This is the equation of what? Work done. Okay. Now, as I already told you and already I have defined that equation from equation 1. What is delta U equal to? Already from equation 1 I can say, from equation 1, internal energy can be given by change in the internal energy. Change in internal energy can be given as, what we'll write, delta U is equals to N times CV into delta T. But what is delta T again? It's final temperature minus initial temperature. So N into CV into TF minus TI. This is what? Delta U. This we got second equation B. Okay. So what is the first law of thermodynamics? Therefore, by first law of thermodynamics, first law of what? Thermodynamics, Q equal to U plus W. I can add delta everywhere. Delta, delta, delta. Okay. So put the value of delta U. It is what? NCV into TF minus TI plus NR TF minus TI. Okay. Now, what is common factor here? See, this is common. So if I take NCV plus NR in one bracket, and this will be in the second bracket, so it is TF minus what? TI. Take N common, then what we'll get? N times CV plus R into TF minus TI. What is this? See, from this Cp can be equal to, but we have, I will write here, but we have Cp minus Cv equal to R. Therefore, Cp equal to Cv plus R. So substituting this value here, therefore I will get Q or delta Q can be equal to N into Cp into Tf minus Ti, or delta Q equal to Ncp into delta T. So where Cp is what? Specific heat capacity at constant pressure. Specific heat capacity at what? Constant pressure. So if pressure is constant, still heat provided is partly used by the system to gain the internal energy and partly used by the system to do the work. So when this is happening, then the system is called as what? Isobaric process or isobaric system. So it's very simple to understand what is isobaric system. If I plot the graph, here one important term that I should say, pressure is not changing but volume is changing. So suppose initial volume is V1 or Vi. So that pressure is say P. Volume changes from Vi to Vf, but still pressure remains same. So this system in which A to B is going on, but volume is changed during this, but no change in the pressure is takes place. This type of system is called as which system? Adiabatic. It called as what? Isobaric process. I hope you understood this article. Thanks for watching mahasarkar.co.in. Thank you.